All right, here we go. Last set of problems in these notes. Let's move on. A particle, traveling on the xy plane has a velocity vector. Yes, it is known that at t equals 1, the particle was at that position. Let's just go ahead and start with, well, we already have in our calculator, we have the first derivative, second derivative programmed in. Don't even have to find them at this point. So let's just type the original displacement. Oh, no, let's not. Whoa, there we go. Here goes. They gave me the velocity. Whoa, glad that problem happened. I'm not going to edit it out. I get in such a habit sometimes of having a position vector. This time I have a velocity vector. Read it carefully. So when I plug this in, I actually am dealing with the velocity. There we go. So this is acceleration now. And this is the derivative of acceleration, which actually has a clever name. It's called jerk. It would be the change in acceleration. So, yeah, jerk has more than one meaning. You're such a jerk. Oh, no, don't call me the derivative of acceleration. I'm going to clear that out because I won't need that. All right, so everything typed in correctly, or is it typed in correctly? All right, we're good. Total distance traveled by that particle. Well, the total distance traveled by the particle is, let's go to the formulas. Look at the formula. Total distance traveled would be that. And they actually gave me the derivatives, okay? So don't be like, well, I have to take the derivative. No, you don't. They gave you the velocity, in a sense. They gave you the derivative. And they didn't give you the velocity in a sense. In a sense, they gave you the derivative. So here we go. Integral from 0 to 5 of what they gave you. So square root of what they gave you. So 4t sine t squared all squared plus negative t squared squared. That would be positive t to the fourth in case you really want to simplify that, and I'd love to, but I'm not. And I want to know the total distance traveled. That is the correct formula. Let's plug this thing in, get this thing done. Math 9, 0 to 5, working 0 to 5. x1 squared plus y1 squared. What would we do before calculators? What would we have done? I predict it's going to be 54 point, hold on, let me think. Whoa. I left my square root off. Okay, here's the answer. It sounds like I said square root off. I am actually recording this in December, getting towards Christmas. So I have made a mistake. I'm going to go with it too. This is correct. This is wrong. I left the square root off, not square root off. So pull that last thing up, and I'm going to type it again. Good learning opportunity. I'm getting in such a hurry here. I don't know why I'm in such a hurry. It's going to take a little longer to compute. Anyway, while it's doing that, let's move to the next one, which says find the velocity vector of the particle at t equals 3, which means I'm going to evaluate the velocity, plugging in a 3 there, plugging in a 3 there, and see, told you. Okay, let's plug in a 3 into both of those. Don't make it harder than it is. This is a good calculator lesson. And I'm going to press alpha trace y1, that is the velocity, at 3, and y1, x1 and then y1, I should have said, at 3. And I have 4.945, and then negative 9. There's my velocity vector. All right, average speed. Average speed, haven't done this one yet, but average value of a function, we've addressed that before, that's where you divide by the width of the interval, so we're gonna do that. Here it is, 1 over b minus a, so 1 over 5 minus 0, the interval from 0 to 5, of this other stuff that looks like the total distance traveled, okay? So I'd love to write all that stuff again. I've already started it, so I'm gonna go for it, but let's be real honest. We can probably do this without a calculator, and well, with minimal calculator, but it would be all the stuff. That's an ugly 4t sine of t squared plus negative t squared dt. You already know what this is. This is 54,844. So this is basically 54,844 over 5. If this was a free response question, you could leave your answer like that. So I'm actually going to just go up and grab that on my calculator. You can just press enter once you get to it. and then divide by 5. And average speed is 10.969, and it does not give me units, so we're just going to stick with that for right now. All right, find the acceleration vector of the particle at t equals 3. Don't make it harder than it is. Plug in a 3 into the derivative of velocity, which in this case is x2 and y2. So clear that stuff out. Alpha trace, x2 of 3. Alpha trace, y2 of 3. And I got negative 63, 953, and negative 6. Okay, find the position vector of the particle for any given time t. Okay, cool. The position would be, oh, fun. Here we go. Yeah, let's look at the formulas. This is where the lesson gets difficult and the calculator kind of goes out the window. Not literally. Please don't throw your calculator out the window. The position would be this. This is the antiderivative of velocity. Well, they gave you velocity. So I need the antiderivative of velocity, but it's not just that simple. So let's do it. Let's just deal with the x first. I'm going to leave a little gap here because I know where this is going. So the integral from somewhere to somewhere of my velocity, which would be 4t sine of t squared and then dt. Okay, so that's the first part of my vector. What's going to happen here as I continue to fill in the gaps and all the missing things is to tell you where the particle is horizontally in terms of x. So this is going to determine where it is. Well, they didn't really give me a place to start or end or anything. And so what am I going to do? I don't know. Let's do it. So I'm going to start at a point that I know and end at t. Okay, well now I've overused my t's, and I want to apologize to you here for overusing the t. But I'm going to change these variables now since I don't overuse a variable. And you're like, man, I don't have any whiteout. Why are you doing this to me? Good practice. Teach you to follow me. Because I have a t up here, I don't want a bunch of t's over here. I need a different variable. And we're dealing with x. It's totally okay to do 4x and sine x squared and then dx. All right, but where does this thing start? Why did I leave this gap here? Okay, this tells me my displacement from 1 to sometime t, but that's great, but what's my starting point? I need a starting point, and my starting point for x is 2. That's it. Okay, so here's my displacement, but my displacement means nothing if I don't even know where I started. So let's do the same thing. I have a starting point for the y. And then I'm going to add to it the accumulated change, the displacement from 1 to t of negative t squared dt. Whoops. Let's not use t. Let's use y because we don't want to overuse a variable, especially when it's up here in the interval. So there we go. And we'll just do it like that. All right, last one. Determine the location of the particle at t equals 3. So what we're going to do is plug a 3 in here and a 3 in here. Love to type the whole thing in. Not going to waste your time too much. I actually have already figured this one out. So just 2 plus, and I want to write it again so you can gain an understanding of what's happening. The interval from 1 to 3. So this is the position at t equals 1. And so I would start here and then accumulate some horizontal movement using this function. And then negative 3 plus, all right. I'm going to go from 1 to 3 because that's my stopping point, and then negative y squared and then dy. And I would type all that in the calculator, bore you to death just to do it, but here it is. 4.903, comma, negative 11.6, repeating actually.